Hello everyone. Let's look at letter combinations of a phone number. The problem statement is we are giving a string containing digits from 2 to 9 inclusive. Return all possible letter combinations that the number could represent. Return answer in any order. A mapping of a digit to letters looks like below. The question is really straightforward. For example 1, input digit is 2, 3, so the output is ADAEAF. BDBEBF, CDCECF. In general, when we see a problem asking us for all combinations, we potentially need to use a backtracing solution. We pretty much build a tree for all possible combinations and traverse all the path. We do it using recursion. Before we even look at the solution, let's look at the input digit string. If the string, the length is 2, like 2, 3, we can simply have 2 for loops. If we know the input digit length is 3, then we can have 3 for loops. But if the input digit length is not predetermined, we basically need to use recursion, because we don't know how many loops we're gonna need. But for this particular solution, the recursive function is really easy to understand. Let's look at the code. We first do the length check. If the digit.length is 0, we simply return nothing. And then we have this digit to letters map. And then we have this output. We will save all the result. And then finally we just need to return this output. Now we can look our backtrack recursive function. What kind of parameters we can pass in? I guess we definitely need to pass in index as I. We can also pass in the current string. And then let's do the check first. So if this index has already moved to the last digit, then we can simply push the current string into our output. If this is not the case, what we can do? We can first get the letter from the map. And then we simply do a for loop. Inside the for loop, we call our backtrack again. In the for loop, we call itself again by passing current string concatenate a new letter, and then we move the index. The recursive method will keep calling itself until it reaches the termination condition. That's the index move to the last, and then we push the result into output. In the end, we can simply run the backtrack method by passing an empty string and 0 index. So if you find it hard to understand the logic, feel free to print out this current and I. Print out the current string and the index. Or you can draw the flow on a piece of paper. Let's try to submit. It passed. Let us look at the complexity. For space, it's O of 3 of m × 4 to the power of n. 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 4 So in here, M represents how many digits that have 3 characters, and N represents how many digits that has 4 characters. Because this is how many combinations we're gonna have, depends on the input. Both input 3 and 2, they have 3 letters. Let's look at the time. I guess for time, that should be the same, because to generate this amount of combination, we need this same amount of time. For this problem, if we do not want to use recursion, we can use a queue to track all the combinations. We can have a for loop to loop through the input digits, and in the input, we first ship an item out of the queue, and then we concatenate it with the next digit's characters, and then push them all in the queue. Let us look at an example here. Say the input digits is 2, 3. So initially the queue is empty. So when we shift out nothing. So that's an empty string, and then we concatenate with all the letters for digit 2, that's A, B, C, and then we push them in. Then we have A, B, C in our queue. And then we move on. The for loop moves to the second digit, that's 3. And then in the first, we shift A out. So we shift it out, and then A will concatenate with D, E, F. So we have AD, AE, AF. Then we push these 3 in the queue. And then we shift B out. And then concatenate with DEF again. We have BD, BE, and BF. And then we shift C out. Concatenate with DEF, we have CD, CE, CF. And then we have done all the iteration, so we have all the combination. Let's have a look at the code base. We can change it into queue. We can remove all these things, and finally, we return this queue. Initially, the initial value for the queue is an empty string. And then let's have our for loop. And then we have another for loop based on the length of the current queue. So this current represents the value that's shift out of the queue. And then with this current, we will concatenate with the corresponding letters like D, E, F. So let's first get all the characters, and then let's do a loop based on the length of this all the characters. So for the map digit, we get all those letters, and then we do a for loop, and then we concatenate this letter to the current string, and then push it back to the queue. And then we keep doing this until we reach the end of this outer loop digit. And then in the end, we can return our queue. Let's submit. It looks good. For the time complexity and space complexity, they should still remain the same. This is because, although these two solutions looks different, but behind the scene, we are still doing brute force to a certain extent, but in different ways. When we need to find all combinations, we literally need to iterate all different input digits and then loop through all letters behind those digits. So the complexity should remain the same here. If you have any questions, please leave a comment below. Thank you for watching.